Welcome everyone. I am JJ. Let's tackle an example problem. So we're coming in and saying, let's determine the resultant of our forces shown here. We're not told to do it a specific way, so we're just going to add up our x and our y components, really our I and our j terms, and then use that to get the resultant force and direction out from everything. So let's just go for it. If I'm trying to get the resultant, let's find the resultant I, the resultant j, x and y. So I'm just going to write that as, if I'm adding that all up to get the total in the x direction, the total I, let's sum my forces in the x direction. Summing our forces in the x is going to get me to, we'll have an x component from F1, F2, and F3. When we tackle forces in the x, we will, unless we clearly say otherwise, positive goes to the right every single time is our assumption. So look at our arrowhead on that. F1 is pointing to the left, so I have to stick this in here as a negative force. This is negative F1's x component. So I want 180 times my 40-degree angle touches the x-axis, so I use cosine. Cosine of my angle, 40. Cosine 40. Then we'll go to F2. It's pointing a tiny bit to the right, so we'll add it in. Plus F2's x component, or plus 120 times my cosine, because we're going to go all the way back to the x-axis. Cosine of 45 plus 30 gets me from F2 all the way to x. 45 plus 30 is 75. Cosine 75. And then one last piece to add in here. I need F3. It's also pointing to the right, so we'll add this in, plus my force, 80. I have an angle that touches the x-axis. I'm adding x components, so I use cosine here. Cosine of my angle is 30 degrees. Cosine 30. If I come in, I would really be getting here, this is, for each term in here, this is the same thing as negative 180 cosine 40 is negative 137.9. 120, or positive 120 cosine 75 will get me plus 31.1. And 80 cosine 30 will get me plus 69.3. And all of those are really an x component. So we could say our units here are I, that's our direction, and pounds for our units on there. But adding all of that up together, our total force in the x on this, our sum of the forces in the x direction, should get me negative 37.5. Negative 37.5 pounds in our I direction. I kind of write those interchangeably. It doesn't matter what order they come out in. That's my total force in the x direction. That will be half of my resultant force. Once I get my total force in the y, I get the magnitude from that, then get direction. So we're just going to repeat this for the y direction. I have, just like I summed all my forces in the x, I could sum all of my forces up in the y direction. Summing forces in the y, we will always say positive goes straight up, negative goes down. So F1, the arrowhead's pointing downwards. So this is negative 180. And because our angle symbol doesn't touch the axis we're taking a look at y, the angle symbol touches x, we use sine. So sine of 40. F2 points down, so minus its magnitude, 120, times the sine of 45 plus 30, sine of 75. And then finally, minus, because it's pointing down for F3, minus 80, sine 30. Or again, getting the actual numbers out for this, negative 180 sine 40. This is negative 115.7. and our units all match here. Minus negative 120 sine 75 is negative 115.9. And then negative 80 sine 30 will get us minus 40. And that would be J pounds. The J because we're working with our Y components. If we add all of that up, we should get that my total sum of the forces in the Y direction is negative 272 pounds in the J direction. Which gets me an X component and a Y component. If I were to try to write this as a Cartesian vector, we can actually do that right now. My resultant force as a Cartesian vector should be, my units are pounds for both, so I'll just pull them out. But I would have my X component, negative 37.5 I plus my Y component, or minus, because it's plus a negative, 272 pounds in our J direction. And pulling the pounds out for everything, we have pounds here. But that would be my second answer for our problem. Let's go ahead and take that and we can move on and try to get to, once I have magnitude and direction, I can get to my magnitudes, I and J, 37.5, 272, and I and J for direction. I can get to a single force and angle from that. So my resultant's magnitude, R, should be the square root of 37.5 squared plus 272 squared. And again, we're ignoring the negative signs on this because a negative squared is the same as a positive squared. We're sidestepping any calculator issues by just putting it as a positive. This will get me, my magnitude here is 275 pounds. From here, let's start plotting this out to see what quadrant we're in. So again, we'll start at the origin on here. So we have our y-axis and an x-axis. We'll always draw our x component first. So negative 37.5, we're going to the left, 37.5. And then we go down, because it's negative, 272. So we go down a pretty far distance, 272. If we complete a triangle here, that resultant is the hypotenuse of our triangle. And our angle, we're getting right here, from the negative x-axis into the third quadrant. Graphically is what we're getting here. If we put this into our calculator, the inverse tangent of opposite over adjacent, negative 272 over negative 37.5, our calculator would tell us we're in the first quadrant. Graphically, we can tell that's wrong. There's value in us not just blindly trusting our calculator. It will get us the wrong quadrant sometimes. Graphing that out lets us kind of sidestep that and see what's really going on for everything. It'll allow us to be a tiny bit more successful with that, which is good for us. But then I can come in and say, using the positive on all these, ignoring the negatives, I'm forcing my calculator to just think it's in the first quadrant. We're outsmarting it. But theta is our inverse tangent of opposite, 272, again, ignoring that negative, over adjacent, 37.5. Or theta comes out to be 82.2 degrees. 82.2 degrees. I can take these two things and pull them into one answer statement then. That my resultant should be equal to, as a vector, so we'll stick that line over it, my magnitude 275 pounds, and my direction, I know I measured from negative x into the third quadrant. So we'll label it to look like that. 82.2. And that would be my final answer, 82.2 degrees, but I kind of ran out of room. But again, we can get through that. If we aren't told specifically if we're supposed to do this as a Cartesian vector or magnitude and direction like this, you should probably default to this one. It's the more common one that we want to use. Cartesian vectors show up every once in a while, but this is how we'll lay out vectors or forces a lot of times. So when in doubt, go with this approach. But hopefully this was useful for you. If it was, hit that like and subscribe. Stick around. Let's get you an A with JJ.